Hello class. Today we are discussing about the capacitor. Before to describe capacitor, we know about some characteristics of conductors. Electric field inside the conductor is zero. It is just outside it, and outside it is normal. Here we have the field. Inside applied field, both are equal, so inside the net field is zero. Outside the electric field is at an angle theta, two components. This transverse component for static charge is zero, so cos theta 0 means 90 degree. मतलब inside field zero आ, सारा field outside आ और normal आ. Charge resides only the surface. But the electric potential is constant at the surface and inside the conductor. Because inside electric field 0, this gradient 0 constant. Outside electric field is perpendicular, so no work is done to move the test charge on this perpendicular electric field surface, that is equipotential. So potential is constant. Now electric field is 0, but potential is constant inside the conductor. And the value of electric field at the surface is sigma per epsilon naught. We have the dielectric, and this dielectric is insulating material in which charge can be induced. Without any actual conducting, charge can be induced. They are of two types, polar, non-polar. Polar, positive, negative charge don't coincide. Asymmetric shape, they have dipole moment. But in non-polar, positive, negative coincide, symmetric shape and zero dipole moment. These are the examples. Now to polarize this non-polar, the process is polarization. Stretch karna atoms nu dielectric slab de under the effect of applied field, the process is polarization. And polarization dielectric slab field reduce kar dendi hai. When a conducting slab, the inside field is 0, but in dielectric slab, the inside field reduced. Here E is reduced, E0 minus EP. And this applied and reduced field ratio is called dielectric constant, or metals de liye dielectric constant infinite. Now we have the term polarization density. That is, when the non-polar is polarized, there is an induced dipole moment, and that induced dipole moment per unit volume, capital P, called polarization density. Induced dipole moment कदों आना ਜਦੋਂ एक non-polar ਨੂੰ ਅਸੀਂ electric field ਦੇ ਵਿੱਚ ਰੱਖਣਾ polarize ਕਰਨ ਦੇ ਲਈ, then that is induced dipole moment per unit volume called polarization density. And this polarization density is proportional to reduced field, and the proportionality sign is replaced with these two factors. This is called susceptibility, and this susceptibility and dielectric constant, they are related by this. And one more, this polarization density is equal to sigma p, induced surface charge density, dipole moment, volume. Induced dipole moment, charge into distance, volume, this is sigma p. And by using this, when we have this value, reduced field, these are values sigma epsilon naught, sigma p epsilon naught, E naught, p by epsilon naught, the value of here, polarization density, this value, and we get this result, that is K is 1 plus chi. Dielectric strength is the maximum electric field that a dielectric medium can withstand without break down its insulating property. Means the maximum field that they withstand without breaking. And for safety, maximum field is only 10% of dielectric strength. मतलब maximum नहीं apply करना, जितना वो bear कर सकता होता सिर्फ 10% apply करना. And its unit is volt per meter. Okay. And the next we have capacitance. That is the ability conductor to store the charge is called capacitance. पोटेंशियल जिन्ना चार्ज देवांगे पोटेंशियल इंक्रीज होएगा, CV Q/B farad. Capacitance depends upon the shape and size of conductor, medium in which they place, not depend on the material of conductor. Spherical, isolated spherical conductor the capacitance, the formula 4πε0 r proportional r. By using this we find the capacity of earth by putting the value of radius, and by putting the value of this 4πε0 we got this value, that is 711 microfarad. And keep in mind, farad is the two big unit of capacitance. Capacitor, the arrangement of conductors to store the large amount of charge and electric energy. Fixed capacitance, variable. These are used in many appliances like the fan, motor, oscillator, radio tuning, ignition system, vehicles, filter circuits, etc. Now for the principle of capacitor. The insulating conductor capacitance is increased when it bring near, when an uncharged conductor connected to earth is bring near it to increase its capacity. That is the principle of capacitor. When air capacitor, there is air between the plate, this is the capacitance. How we find this? The parallel plates, area A, distance D, we have the potential, this value, inside this value, sigma by epsilon naught, sigma Q by A, this value, we got this. And if the medium is changed when the dielectric slab of dielectric constant K completely full space fill करती तब K times capacitance increase हो जाएगी. But if the thickness is small than the distance between the plates, then over to this thickness the field is reduced, but at the space the field is applied field E0. Then how this potential is written? ET, this value, in place of this E we put E0 by K here. Rearrange the term, E0 value, this value, putting this value, we got the result. And if conducting slab is placed, again less than thickness, because in conducting slab inside 0, and for dielectric slab it reduced, for conducting slab it 0. So only this potential is exist, E0 D minus T sigma by epsilon naught, this value. By putting we have this value. When it wholly fill the space with conducting slab, then the capacitance become infinite. And when they are connected in series capacitor, the net capacitance, charge remains same for whole. In parallel, net capacitance, potential in across in capacitor is same. Now the work is done to charge the capacitor, and that work done is stored in the capacitor in the form of electrostatic potential energy or electric field. Work done karna, potential into charge Q by C dQ, integrating we get this value. We have these values, Q is equal to CV Q by B. By putting these values in this equation, the another form. And if this energy stored is divided by this volume, per unit volume, the new term is called energy density for the charge capacitor, represented by this letter. Volume by this, put the value, and this is called the energy density, half epsilon naught E square sigma square upon 2 epsilon naught. We have this table, and this is for giving the answer for very important questions. That is, this is the without any medium, with air medium. This is the capacity, potential, charge, field, potential energy. But when the dielectric is introduced and battery remain connected, the capacitance increase करेगा, potential same रहेगा, charge भी increase करेगा, field भी same रहेगा, और energy भी increase करेगी ਜਦੋਂ battery remain connected होएगी and we place the dielectric in the slab. And when the battery is disconnected, then what we have? The capacitance increases, potential decreases,